Hi guys, Kenna here. So today we're going to go ahead and take a look at acid rain, or more appropriately called acid deposition. The term acid rain is kind of antiquated at this point, but it was originally used to actually cover not just rain, but snow, sleet, hail that happened to have a pH that was fairly acidic. So I use the term acid rain a little loosely, but we're going to take a look at its causes, effects, and some solutions about what we could potentially do for it. So let's look at our essential questions. So number one, what is acid deposition? Okay. Number two, what is the difference between an acid and a base in terms of the pH scale, and how does that relate to the pH scale? Number three, what are the causes of acid deposition? And four, what are the effects of acid deposition? Let's jump right into what I was talking about before, right before we got started. According to the EPA, that's the Environmental Protection Agency, acid rain, or more accurately, acid deposition, is a broad term that includes many forms of precipitation that contain acidic components, like sulfuric acid or nitric acid. The term acid rain was originally coined in 1852 by the Scottish chemist Robert Angus Smith, and has since been known, really known since his publication of his book in 1872, Air and Rain, The Beginnings of a Chemical Climatology. And I'll go ahead and put the link into the post so you can go ahead and take a look at it. But acid deposition typically has a pH of lower than 5.6 and includes snow, fog, dust, not just rain. And so, to better understand acid deposition, I think we need to better understand some basic water chemistry, and that starts with the pH scale. pH scale is a measure of hydrogen ions. If it's acidic, that means there are more hydrogen ions than there are hydroxide ions in the solution. If it's basic, that means there are more hydroxide ions in the solution than hydrogen ions. And an increase between numbers is actually a tenfold in terms of concentration. So an 8 means 10 times as many hydroxide ions than at a 7. Okay. And so that's kind of how we go ahead and take a look at this. The acidic end is as you go from 7 down towards 0, 0 being a super strong acid, 7 being neutral. And bases go from 7 to 14, where 14 is a super strong base, um, and around 7 is neutral. Okay, so it's weak bases. So, what are we talking about when we say acids and bases? Well, chances are you've encountered actually both of these, acids and bases, as they're fairly common solutions that exist throughout our lives. Almost every liquid that we ever encounter in our daily lives consists of either acidic or basic properties, with the exception of pure water. Now, most of the water that we consume, however, coming out of the tap is not pure water, and so it has a little bit of a pH. And so when you see salt water, for example, that's in the oceans, notice that that's like at an 8.5. So that's more basic. So pure water is the only substance that we know of that's really at a perfect neutral pH, unless we make like a synthetic buffer or something like that. Now, normal rain is slightly acidic, and it has a pH of about 5.6, while acid rain, what we typically refer to as acid rain, has a pH typically somewhere in the range of 4.2 to 4.4. So if you think about that, acid rain is a little less acidic than tomato juice. Um, why do you think it is that rain, normal rain, has to be slightly acidic? Pause the video here and think about it. All right, well, what do you think? Well, it turns out that normal rain is slightly acidic, which works really well for plants because plants need to get those nutrients out of the soil. And so the acid helps to leach those nutrients out of the soil, which makes it possible for plant roots to go ahead and absorb those nutrients as they go through in the soil. So I don't know if that's a why, but that's really one of the biggest benefits of that type of thing. So, what are some common examples of acids? Acids, think about citric acid, right? You hear about that a lot with our citrus fruits. So, lemons, oranges, vinegar is an acid, urine is acidic, sulfuric acid, hydrochloric acid, whereas bases are on the other side: soap, toothpaste, excuse me, bleach, cleaning agents, lime water, ammonia water, sodium hydroxide. Now, I wanted to go ahead and point out hydrochloric acid and sodium hydroxide because when we take a look at these examples, what we start realizing is that we can look for particular chemical formulas to tell us if something is acidic or if something is basic. Now, if you take a look at hydrochloric acid for a sample, okay, you'll notice that there's the H and then the Cl, hydrogen and chlorine. Now, this H at the beginning, if these dissociate, becoming ionic compounds, will go ahead and produce H plus and Cl minus. There's that H plus we talked about in our definition of an acid. So typically, strong acids are going to go ahead and have this visible hydrogen ion being able to be released. On the other end, we have sodium, and OH is hydroxide. And if we break this up in terms of our ions, we have sodium and hydroxide. And so that hydroxide ion was something that we also talked about when defining a base. Okay. More hydroxide ions than hydrogen ions is basic. More hydrogen ions than hydroxide ions is going to be acidic. Okay. All right. So let's go ahead and take a look at some more related things to acids and bases. But once again, there's your acid, hydrogen by itself. There's your base, hydrogen with oxygen, the hydroxide ion on that section. So I have a video for you to watch on describing acid rain and acid deposition. Remember that acid deposition, what we normally call acid rain, consists of rain, snow, dust, fog, etc., and other particles, but it's typically going to have a pH lower than 5.6, and we talked about that range of 4 to 4.4. So watch the video, and then we'll come back together.
What is acid rain? Acid rain is any form of precipitation with high levels of nitric and sulfuric acids. It can occur in the form of snow, fog, and even dry materials that settle to Earth. Most acid rain is caused by human activities. When people burn fossil fuels, sulfur dioxide and nitrogen oxides are released into the atmosphere. These gases react with water, oxygen, and other substances to form sulfuric and nitric acid. Winds may spread these acidic solutions over hundreds of miles. After it falls to Earth, acid rain enters water systems as runoff and sinks into the ground. This can make water toxic to crayfish, clams, fish, and other aquatic animals. The rest of the food chain, including non-aquatic species such as birds, is often affected as well. Acid rain also harms forests by damaging trees' leaves, robbing the soil of essential nutrients, and making it hard for trees to take up water. By designing cleaner power plants and using fewer fossil fuels, we can reduce the number of pollutants that create acid rain.
Okay, so some important things there to kind of highlight. When we go ahead and start looking at it, it says most of the acid rain is produced by humans. Remember, we can get this sort of effect from things like volcanoes as well. So it's not just human-made, although we make up the biggest portion of this. And it has pretty major impacts. So we're looking at secondary pollutants here, right? Because secondary pollutant goes up in one form and then is changed into a different form in the atmosphere before it comes back down. We have this condensation of the material and then it falls back to the ground, either as rain, fog, snow, whatever it may be. Even solid particulates sometimes settle out of the sky on their own. And it has a pretty big impact on the wildlife and especially the the water getting soaked up, as we talked about in terms of contaminants back in our water unit. And that affects trees, that affects the aquatic animals, fish. They mentioned the shellfish in particular are problematic, and then that's going to move through the entire food chain. All right. So, what exactly is it? You got a pretty good idea when you looked at the causes of acid rain here in the video, but what causes acid rain? Let's start by taking a look at some of the non human causes. So, rotting vegetation, erupting volcanoes, these can release some chemicals that can cause acid rain. But again, most acid rain is a product of human activities, and the single biggest source is coal burning power plants, factories, and automobiles. In fact, in the 1950s, scientists in the United States started studying this phenomenon, and in the 1960s, early 1970s, acid rain became recognized as a regional environmental issue that affected a lot of Western Europe and Eastern North America. Um, what were they looking at? What were they looking for? Well, there are two kinds of gases they were really focused on: sulfur dioxide and nitrogen oxides. And these are going to react with the water vapor that's in the air. And that's what becomes these nitric acids and sulfuric acids that we typically look at as our acid rain. Okay, so when humans burn fossil fuels, the sulfur dioxides that are released and the nitrogen oxides, the NOxes that we talked about before, are released into the atmosphere. Those air pollutants will react with water, oxygen, and other substances to form airborne sulfuric and nitric acid. As it mentioned in the video, winds then may spread these acidic compounds through the atmosphere, sometimes hundreds of miles. And we talked briefly in our previous notes about the idea of, remember when Mount St. Helens blew up, the ash from that eruption traveled the entire circumference of the globe, went all the way around. So if the prevailing winds are correct, we can travel these acidic materials, nitric and sulfuric acids, miles and hundreds and thousands of miles. And so when the acid rain does reach the earth, then we have to think about the water cycle. So it's going to flow across the surface in runoff water. It's going to enter into our rivers, lakes, and streams. We're going to have seepage where it's going to sink into the soil and it'll end up in the groundwater. And remember, this water is all connected. We all live downstream, and that's going to end up in your drinking water as well. So here's a diagram kind of showing that formation of acid rain. Remember, we start with those emissions, whether it's from industry, transportation, power generation, and we emit those nitrogen oxides and dioxides. Those then react in the atmosphere with water vapor and are converted into secondary pollutants. This chemical transformation produces nitric acid and sulfuric acid, which is then going to either condense in the form of rain, snow, sleet, hail, or you're going to actually have dry fallout where it gets heavy enough to actually have particulates and gases fall out of the sky. And we see precipitation, acid rain, acid fog, acid snow, acid mists, in general, or acid deposition that we've been talking about in today's notes. Um, Now, there are some areas where this poses a greater risk than others, especially in areas where the soil is already acidic or can't neutralize that acid. And as such, it can remove soil nutrients very quickly and cause large amounts of damage to the ecosystems there. Let's take a look at some of these areas. So this is a map of acid deposition problem areas. Um, and I know it's a little hard to see, so we'll zoom in here in a second. But this map shows regions where acid deposition is or may become a problem. These regions have large inputs of air pollution or are sensitive with naturally acidic soils and bedrock. We actually live in one of those sensitive areas because we have more acidic soils. And so we are at higher risk for acid deposition. Now, let's zoom in a little bit. So there you can kind of see it. If you look up here in the Pacific Northwest, um, you can go ahead and kind of see that the whole Willamette Valley right through here, okay, is definitely in this potential problem area because of our sensitive soils. So we have to be extra careful that if this becomes a problem, that we are definitely going to feel the impacts of it. Now, if you look at those current problem areas, you're looking primarily at the eastern seaboard of the United States, a lot of northern Europe, and eastern China. There are a couple other hotspots here and here, but these are the major zones that we typically worry about. Um, Notice that historically powerful industrialized areas are those that are currently having problems with acid rain, primarily due to the use of coal during the turn of the Industrial Revolution and currently higher numbers of automobiles. So, these are the big effects that we worry about when we go ahead and start looking at these high risk areas. And again, remember that here we are in a high risk area. Okay, so now let's go ahead and take a look at the effects of acid rain. All right. Some effects of acid rain are easier to see than others. When you go ahead and take a look at the dead fish washing up on the beach here, or the statue that's getting eaten away, or the big forests that are dying because of, higher risk of infection from beetles and viruses and poor nutrient uptake and these types of things. Um, these are more large scale and bigger impacts, and so they're easier to see. When you see an entire forest like you do there on the right, this virtual tree graveyard is Norway spruce that are found in Poland. But you can see the scars of acid rain. This was caused when the air pollution from sulfur and nitrogen oxides create the acid rain, which weakens the trees by dissolving the nutrients in the soil too fast for the plants to take up. You also start seeing the leaves get weak and fall off. And so you'll see many of these trees are missing their leaves. They're not getting enough nutrients from the soil. And so they end up dying from it. Now, and you think I'm exaggerating here with the statue. Maybe this is broken down from other things, but here's another good example. This is a monument that was destroyed over the portal of the castle in Westphalia, Germany. The monument was made out of sandstone. Now, I don't know how much you know about the different types of rock, but sandstone is a softer material. And the sandstone figure was destroyed because the level of pH that acid rain has is really low number. Okay, and that means that the minerals that are in the sandstone literally melt away due to the high levels of pH, um, high acid in the content in it. And that's why the sandstone figures are destroyed. Um, the evidence here in this picture on the left represents what happened after several years to the statue. Okay, so the one on the left, the picture was taken in 1908. Then the same picture basically was taken again on the right in 1968. So over the course of 60 years, we've kind of destroyed most of this statue. And again, the two big things that we look at are sulfur dioxide and nitrogen oxides. But it's important that you realize that these are not primary greenhouse gases that contribute to global warming. So, in terms of climate change that we'll be talking about next week, these pollutants, while they cause a lot of their own problems, you have to realize that acid rain is really a separate problem from global warming and the greenhouse effect that we'll talk about later. Okay. So, in fact, sulfur dioxide actually has a cooling effect on the atmosphere, but the nitrogen oxides contribute to the formation of ground level ozone, which does end up being a problem, both harmful to the health of human people as well as acting as a greenhouse gas. So, but both gases cause environmental and health concerns, and they can spread very easily in the form of air pollution as winds can take them to areas, in some cases, that are quite a ways away from the actual original production or the point source where the pollutants came from. So, what kind of environmental impacts are we looking at? Well, there are lots of them, especially lakes, streams, wetlands, because we're getting into the water table and that changes the pH of the water. That impacts the organisms that live there, the plants, the animals. So, aquatic organisms are at very high risk of acid rain causing major problems. Um, when it makes those waters more acidic, this results in aluminum absorption from the soil, which then you now have metals which are carried into your lakes and streams. This combination makes the waters incredibly toxic to our shellfish, clams, crayfish, also to our regular fish and other aquatic animals. And while some species can tolerate more acidic waters better than others, some of them are much more sensitive to changes in the pH of their water system. However, in an interconnected ecosystem, what affects one species eventually will affect all the others throughout the food chain, including non aquatic species like birds. Um, when we start looking at other forms, not just the water getting into the water system, but acid rain and fog also damages forests, especially those at much higher elevations. The acid deposits then rob the soil of essential nutrients, as we mentioned earlier, like calcium and aluminum, to be released from the soil, which makes it really hard for the trees to take up the water that they need. At the same time, trees' leaves and needles are also harmed by the acids. And so the effect of acid rain combined with other environmental stressors leave the trees and plants much less healthy. This makes them more vulnerable to cold temperatures, to insects, which were already an increasing problem due to climate change, and to disease in general. The pollutants may also inhibit the tree's ability to reproduce. No reproduction means no new trees, so recovering from this type of environmental problem can be more difficult. And some soils are better able to neutralize acids than others, but remember that map I showed you showing some of those areas that are high risk, and we happen to live in one of those areas. But in areas where the soil's buffering capacity is low, like the US Northeast, like the Pacific Northwest, the effects of acid rain are much, much greater. So I wanted to show you another picture of this. These dead trees line a riverbank near, I think it's called Norilsk, Russia. This is formerly a major industrial center in Siberia and one of the most polluted cities in the world, according to National Geographic. This bears the scars of acid rain. Okay. You start looking at these trees, the fact that there's no real leaves on them, the fact that you've got it almost looks like a forest fire went through. Um, but this is actually acid rain, not forest fire. You can still see some of the greens of the more tolerant plants underneath. So, what does it do? It washes away nutrients from the soil. Remember, acid has to pull it out. That's why the pH of normal rain actually is a little acidic. But if you get too acidic, all those nutrients go out way too fast and plants can't take them up. This can also damage the roots, kills off good bacteria. We have a lot of nitrogen fixing bacteria that we worry about being harmed in this way. And it removes the waxy coating on leaves. This is especially important when we start looking at some of our evergreens. That waxy coat protects them to, over the winter because they don't shed their leaves. And because they don't shed their leaves, leaves that lose that waxy cuticle on the outside are much higher at risk for a disease and for problems associated to those cold temperatures in the winter. And it slows down or prevents completely in some cases the germination of seeds because there are certain seeds that can only optimally grow in particular pHs. And so no new trees. So there's some definite problems when we start looking at plants. But it's not just plants that have major impact. We also talked about aquatic life, but it also has effects on humans. This harms our crops and reduces our plant productivity for a lot of things that we consume. Leaches essential nutrients from the soil, just like it did for trees, but now our croplands for growing food are less productive. Acid deposits may damage physical structures. Remember, we saw those statues as a good example. But if you made a building out of limestone, it's going to wear it away, right? You start looking at the impact on cars, statues, monuments. It can actually corrode copper and lead piping. And we actually have a lot of that in our country. And so, if these things are exposed to acid rain continuously, you're going to see a corrosion or breakdown. It contributes to human respiratory diseases. And when it takes the form of inhalable fog, acid precipitation, that can cause huge health problems, including eye irritation and asthma. And it leaches toxic metals into the environment. We talked about pulling out things like aluminum. Um, this then can get biomagnified, if you remember biomagnification, in our food webs and eventually have us end up consuming it. So, what can we do? Right? What are the things that we can do to help reduce or at least help with acid deposition? The best prevention, the best solution is to prevent it from ever happening. To reduce or eliminate these pollutants from coal fired power and industrial plants is probably the first big step that we can take. And how do we do that? Well, we can go about this in a couple of different ways. One is to regulate the emissions coming from vehicles and buildings, and I think this is an important step. This can be done by restricting the use of fossil fuels and focusing on more sustainable energy sources such as solar and wind power. In the Pacific Northwest, we don't use as much coal powered electricity production, but definitely in several parts of the United States, this is a primary production method. But don't think the only way we can make the problem better is to go ahead and do it by regulations and bills and government. Um, each person can do your part. Reduce the use of your vehicle. Use public transportation when you can. Try walking, riding a bike, carpooling. These are all a good start. Um, Ultimately, we're seeing a shift towards an increasing number of electric cars. I think that's the future. The future is going to be towards electric cars. Now, as we go ahead and start moving that way, maybe we'll see more people using electric cars. And if we can produce electricity without fossil fuels, we've reduced a huge amount of potential pollutants in terms of not only the things we talked about before, but also in terms of acid deposition. Um, you can also reduce the use of your electricity in general. Widely, it's created by fossil fuels and switch to some sort of greener energy package. There are options through eWeb where you can pay a little bit more, and it helps to support their development of renewable energy through things like solar. Many electric companies offer this type of solar package to their customers, and there's no installation fee or anything else. You switch over, and it's not that much more expensive. You just pay a little bit more, and that ensures that you're getting cleaner, greener energy. Okay, so I'm going to leave you today with a video again going over air pollution and tying it into our acid deposition that we talked about today, and those sulfur oxides and nitrous oxides that we've been kind of focusing on. All right, enjoy.
Air pollution consists of chemicals or particles in the atmosphere that pose serious health and environmental threats. But what causes air pollution, and what does it mean for our planet? Some air pollution comes from natural sources like volcanic eruptions, wildfires, or allergens. But most air pollution results from human activities, such as energy use and agriculture. There are different types of human-made air pollution. When we burn fossil fuels to produce energy, they release greenhouse gases into the air. These emissions, such as carbon dioxide, methane, nitrous oxide, and fluorinated gases, trap heat from the sun in Earth's atmosphere, leading to a rise in global temperatures. This creates a cycle where air pollution contributes to climate change, and climate change creates higher temperatures. In turn, higher temperatures intensify some types of air pollution. For example, climate change increases smog because it forms in the presence of high heat and increased levels of ultraviolet radiation. More frequent extreme weather, such as flooding, contributes to damp conditions and therefore to a rise in mold. Warmer weather also leads to longer pollen seasons and therefore more pollen production. Smog is a type of air pollution that reduces visibility and has serious health effects. Smog can be divided into two categories: sulfurous and photochemical. Sulfurous smog is made up of chemical compounds called sulfur oxides. It occurs when burning sulfur-bearing fossil fuels such as coal. Photochemical smog, also called ground-level ozone, is a result of the reaction between sunlight, nitrogen oxides, and volatile organic compounds. Nitrogen oxides come from car exhaust, coal power plants, and factory emissions. Volatile organic compounds are released from gasoline, paints, and many cleaning solvents. Smog not only creates a brown haze that reduces visibility, but also harms plants, irritates the eyes, and causes respiratory distress. Another category of air pollution is toxic pollutants. These are chemicals such as mercury, lead, dioxins, and benzene that are released during gas or coal combustion, waste incineration, or burning of gasoline. In addition to adverse environmental effects, toxic air pollution can cause serious health problems such as cancer, reproductive complications, and birth defects. While air pollution has many consequences for our planet, there are solutions. We can limit toxic pollutants, smog, and greenhouse gases by decreasing the use of fossil fuels, such as in transportation, manufacturing, and electricity generation. Reducing air pollution not only contributes to a cleaner environment and better human health, but can also slow the rate of global warming.
Okay, now next class, we will finish up looking kind of at air pollution before we switch over to kind of climate change and looking at climate change. But we'll talk more next time about smog, for example. So we'll talk about that in terms of some of the things that we look at in terms of air pollution. Okay. All right. That's what I've got for you guys. Stay healthy, stay safe, and I'll see you soon. Take care. Bye bye.